Siapa tahu kenapa yang pertama. Siapa sayang Isa? Oh, okey. Okey, dah dah. Lambat. Ni, kepala aku. Encah.
Okey sikit. Bagi dia hantar lagi.
Tangan tiga lima. Encah. Tangan. Ya Allah. Tangan Encah. 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 Lagi pas sebut Arham. Encah. Situ. Awak sana.
Wow.
Okay, last dah habis. Minggu depan boleh buat tutorial. Okay, this last section of induction motor is single phase equivalent circuit for induction motor. Kalau if you look at the slide, okay, dia sama juga dengan 3 phase. Apabila when we go for 3 phase, okay, when we go for 3 phase, it says a per phase equivalent circuit, right? And all the power we need we need to multiply by 3 for 3 phase power. However, since this is already one phase, so it's already represent a phase equivalent circuit. However, okay, tadi kan previously kan kita sembang pasal operation of motor. Okay, dia ada two different thing. When starting, we need this auxiliary winding. But when operating, we will be remove this winding and left the motor with original pole or original setting or original winding. And when we run this motor, we will be running in original setting, right? Okay. So when original setting, it takes the principle of double revolving field yang awal-awal dalam video tu, kalau you remember. Okay. So the double revolving field kan dia ada cerita, it's mentioned about forward and reverse. So this concept will be applied on the analysis of the power losses and efficiency of your motor. Okay, so don't be surprised why we are dividing this circuit into two. Okay, F mean forward, B mean backwards. Okay, that's why the motor have two slits. Okay, now what we are expanding is this one, this part, we will split into two, but not equally. Okay, the value will be the same from the original. Okay, saya highlight yang penting je. The value will be the same, but it will have a different slip ratio. Okay. If you remember, we have our ZF. This red pop is your ZF, right?
Yes.
Sama. ZF also have. Dua-dua ni sama. This is two same circuit, but with different ratio value. Sebab bila when you split into two, yang atas akan pegang this forward part akan hold one value, one total value, and backward akan hold one total value, but summation between backward and forward akan get back this original circuit. Okay, apa yang different? Apa yang berbeza? Dekat mana? Where is the different ratio tu? So dekat sini. Okay, this one. Okay, when there's no S, meaning that the motor is in stagnant or not moving. Okay, when we have S here, meaning is in operational mode. Okay, so for analysis, kita akan analyse during the operation, right? Kita akan tengok the losses, the efficiency during the operation. So during the operation, yang ni akan per S, yang bawah akan per 2 minus S. 2 minus S. Okay. Yang lain sama. Okay. Others same. So for BEMF, E1, you will divide into 2, E1F, E2, E1 forward, E1 backwards. Kenapa 1? Sebab stator punya, bukan satu circuit 2, sebab E from stator. Okay. And then since this one is 1 ZF, so when we split into 2, dia akan jadi 0.5, 0.5. However, when you move to the back of the circuit or to the right side of the circuit, slip will be assigned in different ratio. 1 over S, this one is 1 over 2 minus S. Okay. Why dia jadi macam ni? Kena sama master lah. Okay, kalau saya cerita tambah lagi 2 jam. Mari kita habiskan apa yang perlu diselesaikan dulu. Okay. Okay, so from here, from this circuit, then you can start to analyze your efficiency and your power. So kita start dengan ZF here, RF plus JFF for this one. Total here is RF plus JXS. Kalau if you notice that we don't have any RC, RC is not mentioned for this one because the core losses, P core, will be included with P what? Will belong together with mechanical or P friction and voltage, PF and voltage plus P strain, and it is called P what? P rotational. Okay. Maybe the value is tak jauh beza pun, so dia last sekali. Okay. And then okay. Okay, if you understand the circle, Okay, the thing is we wanted to find sama juga. We wanted to find the stator current sebenarnya. The stator current here, I1. Okay. So to find the I1, usually you will be giving the B phase value. Okay. However, for this first phase, one phase induction motor, we divided the circuit into two. Okay, divided into two because of the behavior of the winding. Okay, so dia ada forward dengan backward. Okay, so now kita ambil balik konsep three phase. When we wanted to find the stator current is V phase over total impedance. Impedance kan? Kan? So total impedance is from here or from here. Z total. Okay. So Z total is actually yang merah ni. Okay, yang ni this is your ZF and this one is your Z stator, Z1, right? So Z1 plus ZF is your Z total. Since it is one phase, kita divide dia kepada forward and backwards. Okay. Kalau nak hafal yang ni. Yang ni tak bagi. Yang ni tak bagi. Kita bagi formula tapi tak bagi. I won't give you this circuit. Okay. Okay. So forward and backwards 0.5 because 0.5 upper and 0.5 lower level. Okay. Now let's take a look on calculating this ZF because this Z total ni dah clear kan? Sebab dia adalah Z1 plus ZF. Cuma beza yang ni, ZF ni. How to get this ZF? Okay. 0.5 plus 0.5 dia jadi 1. Cuma dia ZF ni field. Ni field. Yang ZF ni adalah forward. Yang ni backward. Tu beza dia. Okay. So to calculate your forward impedance, to make it different kan, you buat notation FWD, backward V, backward BACK. Ialah BWD juga. Okay. So untuk forward, take a look at this one. The R2 is over slip. So R2 over slip. Okay. And this equation is actually R2 over S plus JX2, or actually this one is your rotor, right? Half of your rotor parallel with magnetization impedance JXM. Sebab tu yang ni. And the same concept apply for backwards. Cuma beza dia yang ni adalah 2 minus S. So R2 over 2 minus S. Sahaja. Okay. Another thing, the denominator or nominator? Yang atas adalah nominator. Okay. The nominator part multiply denominator, right? Plus. The upper part, nominator part is multiply. The denominator part is plus. Given. This equation is given. Tapi bila you tulis, yang ni jadi multiply, yang ni jadi plus. Hati-hati So the denominator part is plus, the numerator part is multiply. And forward part is over S, the backward part is 2 minus S. Okay. Dah settle, we know how to find the Z total and we can find the stator current. Okay, why we need to find the stator current? Because we need to find the losses. Okay, already mentioned. This one, the losses. Sama juga. Apa yang lain? Because apa yang lain? The difference is we don't multiply by 3 because it's one phase. Okay. Apa yang lain? Tak ada, sama je. Cuma mungkin arrangement yang ni. Core losses is here. For 3 phase, core losses is here. Okay. For one phase, the losses for core ni usually very small. So dia lump sekali dalam rotational losses yang as been seen on your tutorial, right? Mechanical losses is lumped together with core losses, so it's stated here. Okay. Next, sama power factor. Input, don't forget to don't put 3. Okay, ayat negative. Efficiency, okay. So efficiency is P out minus this one minus ke? P convert minus P rotational, you akan dapat P out. Ingat the milestone you nak P out. So from here minus all over here and you have your P out. Efficiency the same, P out over P in. Okay, tak payah hafal pun, dah auto dah. Next, okay, yang ni lain. Air gap power, it has two component, forward and backward, and the total air gap is minus between forward minus backwards. Yang ni yang lain. Tak apa, yang ni dia beri, don't worry. Yang ni sama, air gap adalah, yang ni apa? Untuk induce kan? Yang ni untuk load, dia bagi dah. Like, P out over motor speed. However, for air gap, yang ni pakai yang ni. And then rotocopper losses, because rotor is having the effect of pulsating forward and backwards tadi. So rotor kita akan take into account the forward and backward of rotocopper losses. How we get it? By using ni. SPAG dan SPAG backward. PAG yang ni. Okay. RF and RB, mana RF? Mana RF? How do we get the RF? This RF is actually this one only. RB, this one only. So they dah counted this difference punya factor. Okay. What else? Continue. Okay. Converter power sama tadi. Okay. Since okay, for converted power dia kata omega m, the motor speed is equal 1 minus s synchronous speed. Okay. Converted power adalah T, induced speed. Omega m. So this omega m actually dia expand from here. So you have the induced 1 minus s, synchronous speed. Okay. Thus for air gap power, you can also calculate it by using the same method. Okay. Alright. Example. Kita nak balik. Example dulu okay. Very proud actually. And I would like to thank for all the kind words that you gave me during the comment. Okay. Mana baik, mana tak. Okay. Alright. So
jangan berani. Jadi aku bagi ganti.
Yang tak ada. Tak jumpa.
Nak je.
Apa-apa kat dia. Text dia kat nota. Ni ke nota saya?
10:55. I think need to prepare for other class. And ada person pun nak masuk. Okay, kita end dekat cari current dulu, okay? So basically, when you already insert the value, okay, dia nak cari, the first one is peak, sama macam same as 3 phase, 150 F over 4, dia tak order point 1 phase or 3 phase, so it is the same. And for starter current, is different between 1 phase and 3 phase equivalent circuit because of the forward and backwards component, okay? So from starter current, you need to find the phase voltage given 110 volts, and you need to find the Z total. And the Z total is came out from stator impedance plus 0.5 ZF and 0.5 ZB. Okay, buat sampai sini dulu pun tak apa. So the ZF here is from this equation, insert from here, and the ZB is from yang tadi saya dah padam. Okay. So the total masukkan dalam ni, baru kira dalam impedance, total impedance for stator current. Okay. Ada dalam slide kan answer dia? You can check this one. Okay. So by right sepatutnya akan dapat 4.66. Okay. Thank you very much for your time. Assalamualaikum warahmatullahi wabarakatuh. Prepare for quiz.